Okay, so we are moving on to Lesson 2, Measuring Matter, and Topic 1, Introduction to Matter, found on pages 14 to 23 in your textbook. We're going to start with the question it. So in the fruit market photo, outline 3 things that have mass. So you can circle any 3 things. Pineapple, watermelon, apples, bananas. It looks like maybe there are cherries there. I don't really know. There's a lot of fruit. There's a lot of fruit there. So you can just circle 3 because every single thing on here has mass. Then we need to answer the question, how much do you think an apple weighs? You can approximate. I would approximate that an apple is about 1/4 of a pound. How do you think an object's mass relates to its weight? So at any particular location, mass is proportional to weight. Mass is constant, while weight depends on the strength of the force of gravity. Weight. So weight is a measure of the force of gravity on an object. It is measured in a unit called a newton, and it is abbreviated with the letter capital N. It's measured using spring scales. 1 newton is about the weight of an apple. Weight changes when gravity changes. The force of gravity depends on the mass of the planet or moon where the object is being weighed. On what planet would you have the largest weight? And the answer to that would be Jupiter. Weight. On Earth, the bananas on the scale weigh 2 pounds. What do you think they would weigh on Jupiter? This is a portion in your workbook, and you are supposed to mark where the weight is, and you would do so here. They would weigh a little bit less than 5 pounds. Mass, on the other hand, is the amount of matter in an object. It's measured in units called grams, abbreviated with the letter G. 1 gram is about the size of a small paper clip. Triple beam balance or a digital scale is used to measure mass. Mass stays the same regardless of gravity. You have the same mass on Earth as you do on the moon. 1,000 grams equals 1 kilogram, and 1 kilogram is equal to about 2.2 pounds. How to use a triple beam balance. To find the mass of various objects. Place objects on the scale and then move the weights on the beams until they balance. The white lines on the right will match up. It's like a seesaw. Next, add the amounts on each beam to find the total mass. What would the mass of the object measured in the picture? So, the big portion is marked at 300. We would take that, then add 70, then add 3.4, and that would give us a total of 373.4 grams. Next, we're going to do our reading check. So summarize. What are weight, mass, and volume? Weight is a measure of the force of gravity on an object. Mass is a measure of how much matter something has, regardless of gravity. Volume is how much space an object takes up. Volume is the amount of space that matter occupies or takes up. You measure a solid in cubic units, so it could be cubic meters, cubic centimeters, cubic millimeters, and you do this by using a metric ruler. You measure liquid volume in liters or milliliters and use a graduated cylinder. 1 centimeter cubed is about 1 milliliter. You can use a metric ruler, graduated cylinder, or beaker to measure volume in a lab. For volume of regular solid-shaped objects, you're going to take the length times the width times the height. So what is the volume of the object pictured if length is 10 centimeters, width is 5 centimeters, and depth is 2 centimeters? So 10 times 2 times 5 equals 100 centimeters cubed. Graduated cylinder. The meniscus refers to the curved surface of water. Read the volume of a graduated cylinder using the bottom of the meniscus curve. So in this image, our number would be 70, and then we go up 1, 2, 3 to 73, because 73 is where the bottom of that meniscus curve is. Then for A, our answer would be 52 milliliters. For B, our answer would be 37 milliliters. And for C, our answer would be either 22.5 milliliters or 23 milliliters. When we get to those, we have to do some estimation because it's not exact, and that is okay. All right, so now we're going to take this knowledge that we've learned and use it to complete our math toolbox. So a reminder that our volume equals length times width times height. So let's read this little excerpt. Objects of regular shape. The volume of an object of regular shape can be calculated by measuring the object's dimensions. For example, the volume of a box-like piece of carry-on luggage that is 20 centimeters deep, 30 centimeters wide, and 45 centimeters long can be calculated by using this formula. Volume equals length times width times height. So what is the volume of the bag? In order to find this, we would take 20 centimeters multiplied by 30 centimeters multiplied by 45 centimeters, which is equal to 27,000 centimeters cubed. Taking this further, large numbers can be rewritten by multiplying a number times the power of 10. For example, because 10 to the power of 4 is equal to 10,000, you can rewrite 30,000 as 3 times 10 to the 4th power. This is called scientific notation. Rewrite your answer to question 1 in this form. And in this form, we would have 2.7 times 10 cubed. Volume of irregular shaped objects or liquids. Water displacement. In this method, you submerge an irregular shaped object in water. The volume of water that is displaced equals the volume of the object. So look at the pictures of the graduated cylinder. A student measured 200 milliliters of water into a cylinder. Next, the student placed a rock into the cylinder and the water level rose to 260 milliliters. How could you determine the volume of the rock? We would do this with displacement, so the amount of water and rock combined minus the amount of only the water equals the volume of the rock. So what is the volume of the rock in the graduated cylinder? It would be 60 milliliters because 260 minus 200 is 60. Objects of irregular shape. One way to find the volume of an irregularly shaped object is by submerging it in a volume of water that is known. The volume of water that is displaced equals the volume of the object. Suppose the irregularly shaped object is a massive whale shark that is about to be moved into a cube-shaped aquarium tank. How might you combine the length times width times height formula with the displacement method to determine the shark's volume? Explain. The height of the water in the tank could be marked before the shark is put in. The volume of displaced water could be calculated by multiplying the change in height by length of tank by width of tank. The displacement would be a measure of the shark's volume. Density is the measure of the mass of a material in a given volume. I like to think of it as the amount of matter packed into a space. Both rectangles take up the same amount of space. Which one has a higher density? Why? So, the one that we have more of in the same space is going to have a higher density. So, of course, the square on the left will have the higher density. All right, for more practice, we're going to rank these blocks in order from least dense to most dense. So one's going to be our least dense, and we're going to place that one here. Our next one will be here, then here, and here. And finally, our last one, 5, is right here, which is the square block that has the most circles packed in. Density is measured in mass per volume units. For example, it could be in grams per milliliter or grams per cubic centimeter. The materials of lower density float on materials of greater density. For example, wood is less dense than water and floats. However, a rock is more dense than water, so it sinks. Water's density is 1 gram per milliliter. And the formula for density equals mass divided by volume. All right, so now we're going to do the model it, liquid layers. So this beaker shows 5 layers of liquids of various densities. The liquids are listed in the table below. We have vegetable oil, honey, corn syrup, water, and dish soap, each with its own density. We need to complete the model by using different shading for each layer shown, according to the densities in the table, then label each of the substances. So, we are going to find the liquid that has the greatest density, which is going to be honey. We're going to make a dark coloring here and label it as honey. Then we're going to find the next highest density, which would be corn syrup, and do the same in a different shade or lighter shade. The next one would be dish soap at 1.03, and then water is going to be on top of that at 1. And finally, vegetable oil is going to float on top of everything at 0.91 grams per milliliter. And again, based on the knowledge that we just got, that lower density objects will float on higher density objects, that's how we decided what order these would go in. Honey would be at the bottom, then corn syrup, and lastly vegetable oil would be on top of all of the other liquids. Understanding the formula for density. Determine the effect on density under the following circumstances. 1. If the value of mass doubles, but the volume stays the same, the value for density will be halved, doubled, or the same. And it's of course going to be doubled. If the value of volume doubles, but the mass stays the same, the value for density will be halved, doubled, or the same, and it's going to be halved. If the values for both mass and volume double, the value for density will be halved, doubled, or the same. And if they were both doubled, your density value is going to be the same. Temperature affects density. Density is a physical property of matter and stays the same regardless of the size of a sample, as long as each sample is made of the exact same substance. However, one way to change the density of a substance is to change its temperature. All matter is made of molecules, and those molecules are always moving. Increasing the temperature of a substance makes the molecules move faster and push further apart. Which image shows the beaker of liquid with the highest temperature? So we're looking for ones that are moving faster and further apart. And the answer to that is not going to be A, because they are very close together and not moving at all. So if we compare B and C, C has the longer streamline on it showing movement, and they are even further apart. So our answer, of course, is going to be beaker C. Temperature and density. So which sample shows warmer air? Which sample shows cool air? Which sample of air is more dense and which is less dense? Which sample of air would tend to rise? So warm air is sample B. Cold air is sample A. Cold air is more dense and warm air is less dense. Warm air will rise and cold air will sink. Temperature and density. Temperature does affect density. Temperature is measured in degrees Celsius using a thermometer. Most substances become less dense as temperature increases and more dense as temperature decreases. Example, warm air masses rise while cold air masses sink. So figure 4, density in water. When people throw coins into a fountain, the coins drop to the bottom. Why do the coins drop to the bottom of the fountain? And the answer is that the density of the coins is greater than the density of water. Now we're going to do the math toolbox here. So, temperature and density of water. Although the density of water is usually considered to be 1 gram per cubic centimeter, the true density of water varies with temperature, as shown in the table and graph. So, we have at 0 degrees Celsius ice, the density is 0.9168. For water, it is 0.9998. At 4 degrees Celsius, it's 1. At 10, it is 0.9997, and at 25, it is 0.9977. So, at what temperature is water the densest? And according to this graph and this chart, water is going to be densest at 4 degrees Celsius. Explain the sudden decrease in density when water is at 0 degrees Celsius as shown on the graph. And water freezes at 0 degrees Celsius. The sudden decrease in density is due to water changing from liquid to solid ice. Finally, if ice were, like most other substances, more dense than its liquid form, what would this mean for bodies of water that freeze in the winter? What would happen to the organisms that live inside them? So as ice formed where liquid water meets frigid air, it would sink down and be replaced by another layer of ice. This could continue until the whole body of water was frozen solid. If this were the case, organisms would then be killed or die because of this, and they wouldn't have an area to live and breathe. All right, using density, page 20. Density does not change with the shape of an object, so it can be used to identify a substance. We're going to find out which sample is gold. So first we need to calculate the density of each substance. Sorry. So we're going to take our mass, divide it by our volume. So 284 divided by 14.7 is 19.3. We're going to continue doing that for each of our samples. Muscovite is 67.2 grams divided by 24, which is 2.8. Biotite is 60 grams divided by 20, which is 3 grams per cubic centimeter. And pyrite is 120 divided by 24, which is 5.0 grams per cubic centimeter. I did not label them as grams per cubic centimeter, but you should do that in your textbook. So now we need to identify the substances based on the densities. So the 5.0 grams per cubic centimeter, according to our density calculations, is pyrite. 19.3 is gold, 2.8 is muscovite, and 3.0 is biotite. Now to answer our final question, besides density, what other physical property can you use to confirm that the gold is indeed real gold? And for this, we could look up the melting point of gold and melt the rock and see if it melts at the known melting point. So density in summary. Density is a characteristic property of a substance and can be used to identify a substance. The density of a substance is the relationship between the mass of the substance and how much space it takes up, or the volume. The mass of atoms, their size, and how they are arranged determines the density of a substance. Density equals the mass of a substance divided by its volume, or the equation D equals m over v. Now it is time for our lesson 2 check, which can be found on page 21. So what is the mass of a sample of a substance with a volume of 120 milliliters and a density of 0.75 grams per milliliter? So we are going to take 0.75 grams per milliliter and multiply it by the volume to get the mass. So 0.75 times 120 is 90 grams. If density usually increases with decreasing temperature, why does ice float on liquid water? And water is an exception to the rule. Water is densest at around 4 degrees Celsius, and it is ice at 0 degrees Celsius, so ice is less dense than water. 3. Why is mass a better unit for measuring matter than weight? And weight is affected by the force of gravity, which varies. Mass is strictly a measure of how much matter something has. The force of gravity on the moon is only 16.6% of the force of gravity on Earth. For each item listed in the table, fill in what its weight would be on the moon. So, the weight on Earth is 150 grams. On the moon, it would be 25. A hammer is 1.5 pounds, it would be 0.25 pounds. A person is 180 pounds, they would be 30 pounds. And a blue whale is 200 tons, and it would be 33.3 tons. So a small bar of pure gold, whose density is 19.3 grams per cubic centimeter, displaces 80 milliliters of water when dropped into a beaker. What is the mass of the bar of gold? It is 1,544 grams or 1.544 kilograms. What might happen if a large cloud in the sky suddenly encountered a colder air mass with a temperature of 5 degrees Celsius? The density of the cloud would increase, so the water vapor might condense. In much of the world, SI units, or the metric units, are used in everyday life, and not just in science. Why would it make sense for people in the United States to use SI units in everyday life too? Explain using the terms calculate and convert. It would make sense to use SI units in the US so that a person from the US would not have to convert their units to SI units when traveling abroad or speaking with people from another country. For example, if a person from the US drives a car in Canada, they have to calculate their speed in kilometers per hour based on the conversion rate between miles per hour and kilometers per hour. Using SI units all the time would fix this inconvenience. And that finishes this lesson.